Huh? Tangent to the fourth? The antiderivative of tangent to the fourth x? I think we did tangent to the fifth. Let's see, it's in my book. Yeah, tangent to the fifth, I think was the last one we did. One before that, was it tangent to the fourth? Or do you see a tangent to the fourth in your notes? Well, we'll go ahead and try tangent to the fourth, because I can't remember if we did it or not. Let's try the antiderivative of tangent to the fourth of x. Go ahead and break it up, because you know you're not going to be able to do anything with it tangent to the fourth. So you're going to have to break it up into some kind of and of course that would be tangent squared, correct? Antiderivative of tangent squared x times tangent squared of x dx. Now, using Pythagorean identities, you know that the tangent squared of x is equal to secant squared minus 1. And you know that because of the Pythagorean identities. Right here. So tangent squared is equal to secant squared minus 1. Right there. I'll try to blow it up some more. Right here. So use secant squared minus 1 in for one of the tangent squared. And the reason you do that is because you got to get some kind of secant tan, because you know that the antiderivative of, or the derivative of, the antiderivative of secant squared is equal to tangent. So you know there's some kind of relationship between secant and tangent. So that's why you want to put secant in there. So tangent squared x times secant squared x minus 1 dx. Now you can distribute the tangent squared. You get the antiderivative of tangent squared of x, secant squared of x dx, minus the antiderivative of tangent squared of x. And of course you can turn that tangent squared into secant squared minus 1 again. tangent square root of x, secant square root of x, dx, minus secant square root of x minus 1 dx. And then that's going to give you antiderivative of tangent square root of x, secant square root of x, dx, minus the antiderivative of secant square root of x dx, minus the antiderivative of dx. Now finish it out, and you know that the antiderivative finish it out. Knowing that the antiderivative of the tangent of secant square root of x is equal to the tangent. So your final answer is tangent cubed x over 3 minus the tangent of x minus and the antiderivative of 1 dx, or is x. And that's your final answer. It was. Because you distribute that negative. Don't know if we did this one or not. Excuse me. Antiderivative, secant x over tangent squared of x dx. I would probably use my reciprocal identities on this one because you can't do much with that secant of x except turn it into a reciprocal identity. Now, the secant squared of x, it'd be different. So you can at least simplify it a little bit by using the reciprocal identities. Antiderivative 1 over cosine of x over sine squared of x over cosine squared of x dx. And like I said before, the reason that you don't use the secant tangent relationship is because that secant, you can't do anything with secant. Now, if it was secant squared of x, then you could do something. But it's not. Take a few minutes and work on that. antiderivative of 1 over the cosine of x times cosine of x over sine squared of x dx, and that's going to give you antiderivative of cosine of x over sine squared of x. And now you've got something to work with in a relationship between sine squared and cosine. Because you can bring that cosine squared, sine squared up, and it'd be sine to the negative 2 of x. And then you'd have u du. Or antiderivative of cosine of x times sine negative 2 of x dx. And of course, you could turn that around antiderivative of sine negative 2 of x dx, times cosine of x dx, and that's u du, so that would be sine to the negative 1 of x over negative 1. Bring the negative out. So negative sine to the negative 1 of x, or negative 1 over the sine of x plus c, and what's 1 over the sine of x? Cosecant. You could write it as negative cosecant. So, I spent a little bit of time on this manipulation because it does help you tremendously to be able to manipulate using the identities, as well as just manipulating to get some kind of relationship, so you can take the antiderivative of something using u du or using some kind of relationship. So it does help you, especially when you're manipulating in Calc 3 and DiffEq. The next section we go over, I think, is trig substitution. So we'll go over that next. I think that's 7.3. Look and see. Yeah, 7.3 is trig substitution. So let's move on to that. And if you have your book, it's on page 478. And I would say one of the most helpful section, they should have shown it by now. I don't see it. They should give you the whole. They're not giving it to you. I thought they would give you this. Probably giving it to you afterwards. Let me see if I can find it. Usually they give it to you. Nope. They're not giving it to us. Okay. Alrighty. Let me just write it down from my notes then. They're giving it to you right here, but they're giving it to you in a lump clump. There we go. There's what I was looking for right there. Sorry. You got your sine, tangent, and your secant right here. And you need to know those three arrangements. You got your a squared, which is going to be your number minus your variable squared. You got your a squared plus x squared, and you got your x squared minus a squared. So you need to remember those and the relationship from there to sine, there to tan, and there to secant. So your best way to understand it is doing an example. Make sure you get that down. Hold it up so everybody can get it. And let's go with an example. Go with the antiderivative of 1 over square root of 4x squared plus 1 dx, or antiderivative of dx over square root 4x squared. Okay, so take a minute and work on that for a second and see if you can match it up and see if you can get it started. You know it's going to have some kind of relationship to secant and tangent. Why? Because it's a squared plus b squared, or a squared plus x squared, or x squared plus a squared. form, this tells you that you've got a triangle with 2x here and 1 here, and the square root of, what is it, 4x squared plus 1? How do you know that? I just threw it up there, just why didn't I put the 1 over there where the 2x is? How did I know that? Okay. Nobody has any clue. Look at the box that I just showed you. So I told you to write it down. Where is it at, buddy? Can't even find it. What does it say right here? It says x is equal to a tan of theta, Hubert. Thank you, class. So what's the tangent of theta equal to? Tangent of theta is equal to what? If I wanted to get the tangent by itself, what would I do? Okay, so x over a is equal to the what? Tangent of theta. And what is tangent? Oscar had a hunk of apple. Tangent equals what? Oscar had a hunk of apple. Opposite over adjacent. And that's where you get. Y'all never heard of Oscar had a hunk of apple. Well, that's part of your problem right there. Who'd you have for trig? A piece of grass? Oh, Sokotoa. Okay. If y'all Sokotoa people, then what is tangent? Toa. Whatever Toa is. Let me get like y'all. I don't know what Toa is. What is Toa? That's what y'all sounded like. Just quit then. Yeah. Okay, for normal people that take trig, Oscar had a hunk of apple. So tangent equals opposite over adjacent. And the opposite is always across from the theta. And adjacent, you put a little man right here, his legs are always on the hypotenuse and the adjacent. So that's how we put the 2x over 1. Because in this little do-jigger right here, then right here, alright, is telling you that x is equal to a tan of theta. X is equal to a tan of theta by your rule. Okay, so solve for tan. So by the rule, the tan of theta is equal to x over what? What is our x? I'm sorry, x is, 2x. Over 1. So by your rule, you have 2x over 1. By Sokotoa, what is 2x? what is 1? The adjacent. And that's how you know. By the relationship between your x over a and your colon. So now you got this. So the tangent of theta is equal to x over a. So with that, or the tangent of theta is equal to 2x. With that, you can find out what x is equal to, solve for x, and then find dx. Because if you have x, you can take the derivative of x. So what is x? We know that tangent of theta is equal to 2x, right? So what would x equal to? Tangent of theta is equal to 2x. 2x over 1. So divide by 2. Divide by 2. X is equal to 1/2 tan of theta. Is that fair to say? So x is equal to 1/2 tan of theta. And if we have x, then we can get what? Dx. Why do we need dx? We need to put something over this. We need to put something right there. So find dx of 1/2 tan theta. What's the derivative of tan? Dang old secant squared, Hubert. That's right, class. Y'all about ready for that ditch, aren't you? Now, what's this section called? Trig what? Trig substitution. So you got dx now. That dx can go where? Up top. Say again? Oh, thank you. Okay, so now that 1/2 secant squared theta can go right there. Now you also know that the secant is equal to the square root of 4x squared over 1 over 1. How do you know that? Well, let's go back to SOHCAHTOA. What is the secant? Well, it's the reciprocal of the what? Sine, cosine, tangent, cotangent, secant. So it's hypotenuse over what? Adjacent. So the secant, let's go over here. So secant, let's just write it over here, is the reciprocal of this guy. Cotangent, secant. And the secant is equal to h over a, which is equal to the square root of 4x squared plus 1 over 1, or the square root of 4x squared plus 1. So I can put what right here? Secant. So using these three things, and I'm going to go to the next page, and I'm going to say x is equal to 1/2, I don't forget, tangent of x, and dx is equal to 1/2 secant squared of x, and secant is equal to secant of theta is equal to the square root of 4x squared plus 1. Using these three things that we ascertained from the first page, the front page of this page, we can rewrite antiderivative of dx over the square root of 4x squared plus 1, make sure I wrote that down right, as the antiderivative of dx over what? All right, now do something with that. You should be able to do something with that. If you can't do something with that, then yes, you need to get your cardboard box ready. Because you're well on your way to living in that ditch. And working at Target, right? He's not even listening. I was picking on you. Target, I think Target's a good place to work. The women are hotter than Walmart, that's for sure. Walmart's getting to be skank town, I'm sorry. Walmart has turned into a ghetto, I'm sorry. I don't care where you have, I believe, I don't even believe Hilton Head Walmart. I mean, I believe it's probably done gone. I don't know what it is, but I mean, I went to Hartwell Walmart the other night, and it was even, and Hartwell Walmart's pretty decent. 1/2 comes out, and that gives you secant squared of x over secant of x. And of course, that cancels. And 1/2 antiderivative of secant of x. And y'all help me out. What is secant tan? So that'd be 1/2 the absolute value, wouldn't it? Of secant tan. And there's only one more step, and that is secant plus the tan. Is take your secant tan and put it back in. And what's your secant? Square root of 4x squared plus 1. And what's your tan? You got the tan is equal to what? 2x? Y'all help me out there. So 1/2 antiderivative of square root of 4x squared plus 1 plus 2x. Plus what?
Don't forget to add the plus C, or I will not get it wrong.
So, you set up the trig, then you substitute the trig, and then what do you do at the end? Substitute back in, just like you did with UDU. Remember the UDU, you would change it to U, then you would go back and put the U back in. Same thing here. You change it to trig sub, and then you go back and change it back. Now, it kind of helps. What helps? This right here helps. Let's take our red marker and this guy kind of helps you know what to do based on this right here and your SOHCAHTOA. I don't know what that means. And your SOHCAHTOA in relation to this guy right here. Okay. Basically, the tie-in here and here is based on your box, the rules for trig substitution. And this, you learn back in trig. You have to set that relationship up. So you think that cardboard box is getting a little bit comfortable? It's always easy to what? To learn. Dx over x squared plus 1 to the 3/2 power. I want y'all to do this one. First thing you want to do is make that 3/2 into what? Radical, Hubert. That's right, class, because you know your rules are in terms of radicals. Ew. Yeah, I went to Target the other night, me and my daughter, and that's what we usually do because she knows all our stuff. So I was in the candle section because I like to buy candles. Met 2 women in the candle section. Yeah. At least I know their house smells good if they buy candles. Huh? Yeah, that's true. They may just leave them sitting in the window. So that would be the square root of x squared plus 1 to the 3rd power. Working with the tangent again because it's going to be the plus. So y'all should be able to knock this one out real easy. Went to Tractor Supply yesterday, or the day before. It was Sunday. I think it was Sunday. And there was this truck in the parking lot. I parked right where I could see it. I wanted to see who come out of Tractor Supply and got in. They never did come out. So anyway, it not only had the ultra big tires on it and the 15-foot lift kit, it also had 2 smokestacks coming out of it. But these were not just smokestacks. These smokestacks were at least 6 foot higher than the cab, the roof of the cab of the truck. So these were ultra retarded smokestacks. I'm not going to tell you. Somebody might know somebody. So it is a white F-250. I mean, if you're going to put all that on it, at least make it dual. I mean, this guy's getting on my nerves. I mean, I do teach for a living, and he just keeps calling and keeps calling and keeps calling. These things are like 6 foot high. So the cab was probably, you know, I don't know what your standard cab is, but this had the 15-foot lift kit on it, so it was already, I don't know, 8 foot off the ground. So, and then you had 6 foot. So then they were topping 14 foot. Never did see who got in it. I was wanting to video it and see if it was a short, bald-headed guy. I really don't remember that. Yeah, it probably was, but this guy does have the. I mean, these smokestacks were tall. Oh yeah, it helps the power. That even makes more sense. Yeah, that makes more sense.
A big foot wide smokestack. They were going around PCTC with a fall on their truck, blowing it off of the parking lot one day.
Sounds like a real winner.
Yeah, black smoke and a lot of fall.
Oh, they put chips in trucks now to make smoke black.
You have to refill the smokestack with other stuff.
Yep. Don't know why you want to do that. I mean, maybe it's some kind of
The black smoke's side of the chip is where it remaps the PC on fuel,
yeah.
make more power. And then it works.
I thought the smokestack made more power.
20 horsepower piece. That and as many stickers.
What if you have a butterfly on it? If you have a butterfly at the top, does that hinder the power, or does that make more power? Oh, it hinders the power. Okay.
I was thinking about this, that takes all that time.
You might have too much if you put 2 of these stacks. Maybe you put 3 smokestacks. Would that make it triple the power? Oh man.
That's all they got, that's all they actually have like a chimney, so like bricked up chimney. Yeah, it's like, I don't know, that's cool.
Okay, so this is tangent because it's plus, and this is basically, let's see if I can rewrite this, dx over the square root of x squared plus 1 to the 3rd power. Is that good? So therefore, your x is x, and a is 1. So x1, and this is the square root of x squared plus 1. And to make life easier, we might want to put that 3 on the outside to make life easier on us. Like that. So we know that the tangent of theta is equal to Oscar had a of apple. I'm sorry, something Koa. Koa, the x over 1. So multiply both sides by 1. And x is equal to tan of theta. Therefore, dx, what's the antiderivative of tan of theta? Secant squared of theta here. And we know that this is equal to the secant square root of x squared plus 1 is equal to the secant. So secant is equal to, secant of theta is equal to the square root of x squared plus 1, or or secant is equal to Oscar had A hunk, hunk A be this over this. So now you can take all this information and finish the problem. I just got to remember what the problem is. So let's take this up here. And the problem is the antiderivative of the dx of square root of x squared plus 1 to the third power. So that's going to give us dx is what? Secant squared of x over what? Secant what? Cubert. And that'd be the same thing as secant cubed of x. So antiderivative of secant squared of x over secant cubed of x will give us what? 1 over the secant of x, which is equal to reciprocal identity, should be what? Cosine? So the antiderivative of the cosine of x is what? Sine? Sine of x plus c. And in that case, we need to find the sine of x. And what is the sine? Oscar had. So Oscar had, let's go back. Oscar had, so that over that. So that'd be x. So x over the square root of x squared plus 1. And you could rewrite that rationalizing the denominator, which would be a mess, but I don't know what they want, so let me see what the answer is in my notes. Yeah, that's it. X over the square root of x squared plus 1 plus c. Now there's two tangents. You should be able to knock out tangent real easy. So I need to discourage you with something else. Oh, this is a mess. You can try it. I don't know. Some of y'all might head on to the ditch on this one. Antiderivative of square root of x squared minus 3 over x dx. And take a minute and see if you can work with it. You know that it's x minus a. So x minus a is going to give you what? Some form of the secant. And you know that by your little box. Oscar had a hunk A, so that means you've got the hypotenuse over the adjacent. The reason we didn't have class last Thursday is I had a virus. That sucker knocked me out from Wednesday night till Sunday. It wasn't the flu, it was just a virus. I don't know what it was, but it was rough. I got out of bed, I finally got out of bed Sunday. I worshiped the porcelain goddess for the 3 daggum days. Finally got tired of running to the bathroom, so I just put a 5-gallon bucket beside the bed. What? Well, why run back and forth to the bathroom? I mean, you feel like crap already, unless you just want to feel like more crap. So I just put a 5-gallon bucket beside the bed. I thought it might have been food poisoning, but my son ate everything I ate that day, so he didn't get sick. So it wasn't food poisoning, it was a virus. So I must have picked it up from one of y'all, doorknob, bathroom, something. I picked it up from a student or something. Oh, y'all, it's all Bush's fault. All right, now by the little chart here on page 478, x is equal to a secant of theta. So write that down. X is equal to a secant of theta. So we've got to find out secant of theta. Huh? You should say secant. Secant theta, cardboard box, x over a. So we got dang old fine, there's dang old x. So let's rewrite this as the square root of x squared minus the square root of 3 squared over x. So x is equal to x and a is equal to what? Square root of 3. So x over the square root of 3 is equal to the secant of theta. We know that the secant, by our trig definition, what is our secant? Oscar had a hump, hump A, so hump A. So x is your what? X is your what? Hypotenuse. That's right, class. And what is the square root of 3? Your adjacent. Because your little man on theta always has his foot on the hypotenuse and the adjacent. So it matches up. So what is your opposite side? What is it? Square root of x squared minus 3, right? Yes, you class. Didn't want to erase that. Wrong place. Alright, so your secant of theta is equal to this, so we need to take, let's see, x, a secant of theta, so x is equal to secant of theta, and then dx, you need to find dx of secant of theta. And dx is going to be square root of 3 secant tangent if you take the derivative of the secant. So x is equal to, multiply by the square root of 3, square root of 3, secant theta. Therefore, dx is equal to square root of 3 times secant tangent theta. Now all we have to find is, what is the square root of x squared minus 3? Or we could, let's see, divide by the square root of 3. I'm just thinking out loud. Got the square root of x squared over 3 minus 3. The tangent would be, Oscar had a hunk of apple. Yeah, the square root of x squared minus 3 over the square root of 3 would be your tangent. So that would help us too, down here. So the tangent would be, tangent of theta is equal to, Oscar had a hunk of apple, square root of x squared minus 3 over square root of 3. You could rationalize the denominator on that, but right now we just, so here's what we need to do our dx and all that good stuff. We got to plug everything in. So we've got the square root of x, multiply this by 3, so that'd be the square root of x squared minus 3 is equal to the square root of 3 tan, and then dx is equal to this, so that's going to be that, and then x is equal to this, so that's going to be that. So go ahead and plug everything in. And that's the easy part. Antiderivative of the square root of x squared minus 3 dx over x. Oops, that's z. I'm going to go right here and I'm going to say multiply both sides by square root of 3. So this is equal to that. So square root of 3 tan of theta is equal to the square root of x squared minus 3. So that's going to be square root of 3 tan of theta here. I'm going to put brackets right there. And then dx, right here, I'm going to put in parentheses. Dx is equal to all of this Square root of 3, secant theta, tan theta, all over what? Square root of 3 secant of theta. And of course, the 3 cancel. Square root of 3 you can factor out up here and take that out because these cancel. So that's going to leave you with tangent. Let's see. Now you're going to have to distribute that to cancel. Tan secant, tan. No, I'm sorry, that's not close. So that'd be secant tan squared over secant, right? Huh? What? The square root of 3 should cancel. They should all cancel. Square root of 3 times square root of 3 is 3 over the square root of 3. Okay, we'll leave them. Just forget that. We'll leave them there. Okay, we'll leave them right now. I don't want to do anything yet. I want to go ahead and let's go ahead and if we took the square root of 3 times square root of 3, what do we get? 3. And then that's going to be tangent squared secant, right? Right. Thank you, class. Always good to have class behind me. Tangent squared over square root of 3 secant theta. And what happens to the secant? And that you're left with bringing 3 over the square root of 3 out. Antiderivative, tangent, squared theta, d theta. And square root of 3, that'd be 3 times square root of 3 over 3. And the 3's cancel, and you're left with the square root of 3. Square root of 3 times the antiderivative of tangent squared theta. Make sure I did that square root of 3 right. We got Yep. I think I got it right. I got square root of 3 outside my answer. All right, now what can we do with that tangent squared theta? Well, change it into secant squared minus 1, right? That's what I would do. So it's square root of 3 times the antiderivative of secant squared of theta minus 1 d theta. So it's square root of 3 brackets the antiderivative of the secant squared of theta, c theta, minus the antiderivative of d theta. And square root of 3, that should be tangent theta minus theta.
plus
And you feel good about yourself, right? So you don't have to add those butterflies or that third smokestack. All right, I think we did, let's try one with the sine, or we did one with the tangent, we did one with the secant. Let's try one with the, see if there's one in the book, a squared minus x squared. I'm looking, just give me a minute. $12 looks like. Yeah. Let's try number 12. Pull it out of the book for you. Dang old Geico commercials in my head. Y'all don't get them in your head, do you? Every once in a while. I like the Geico commercials. I can't stand the one with the little lizard. I can't stand those. I wish somebody'd step on him. All right. What? Yeah. You could save money with
All those ones when they keep really fast behind.
Yeah.
They just barely got it.
All right, try this one. I would quit.
Parent with some bad special effects.
Yeah.
He turned around and his family like squirting tomato juice or something.
Okay, you're getting a little bit gross now.
Have you seen Monty Python and the Holy Grail?
I don't know.
They could use the effects from the Black
Mm.
Knight.
I watched Monty Python one time and I was like, okay, when's this supposed to be funny? Some people's sense of humor is not the same as others. It does. It does. I don't have it. I would much rather see a drunk. I would much rather get a drunk. I'd much rather watch a drunk person get tased than that. I don't think that's funny. To me, a drunk person getting tased is the most funniest thing in the world. Besides them getting beat up, I mean, it's just hilarious. I understand it. I love it. Especially when they beat up on the drunk people. No coughing in class. Okay, now that information right here is nothing really new. This is, everything above here is pretty much simple. First thing I did is I rewrote this, and then I got my A and my X. You know that the sine of theta, this is in the little box. So sine of theta is equal to x over a. Well, since we got our x, A and our x, goes right there. And we know that from trig, it's the opposite over the hypotenuse. Pretty simple. That's pretty simple. Now, if we know that the sine is equal to x over a, then we need to solve this for x. So x is equal to a is what? What is that? 5, square root of 5? So that's the square root of 5 sine of theta. If that's equal to x, then dx, the derivative of the sine is the cosine, right? So square root of 5 cosine of x, or cosine of theta. Huh? And now you just got to find the relationship out with this right here. And we have to find u, which we could, well, solve for u. U is equal to the square root of 5. X and u is equal to the same thing. You can put u right here also. Because you need that u right there. had a hump of apple. Oscar had a hump. A hump would be the cosine. So cosine of theta is equal to a hump would be square root of 5 minus u squared over square root of 5. So the square root of 5 cosine theta is equal to that. So the square root of 5 minus u squared is equal to the square root of 5 cosine of theta. Now that, this, and this, and this, you'll substitute back into that, which this is du or dx. So let's just rewrite this. Du over u times the square root of 5 minus u squared. Put it on the blackboard when I do. See if I do it. This thing is this. We all know whose fault it is. You know, in an interview the other day, this was just a couple of days ago. President Obama was asked, where does ISIS come from? And he said, it's Bush's fault. He said that ISIS comes from the invasion of Iraq. Yep, I agree with that. They just sat around, didn't do anything until we left Iraq in the wrong way. We left Iraq. Who was in charge of that? I guess Bush was in charge of that too. We left Iraq in a vacuum sort of way that whenever we left, there was no what? Fences there for the Iraqis. So our ISIS took over. So I guess it's Bush's fault that we left Iraq the way we did. I'll be glad when 2016 gets here so we can at least get a better, I ain't going to say a better president. I'm going to say, well, we're going to have idiots no matter what. I just forget. We're just doomed.
Are you a Hillary fan?
No, I'm not a Hillary fan, but Hillary or a stiff, white, rich Republican, because that's what Republicans are going to nominate. They're not going to nominate a woman. They're too arrogant. So I guess we're just stuck with either Hillary or a stiff, rich, white male, because that's what we're going to get for 2016, one of those two.
I think John McCain was one of
John McCain was a stiff, rich, white. That's not going to be elected now. And the Republican Party will not get that out of their head. They're too arrogant. They need somebody young. They need somebody diverse. They need somebody, maybe a woman, maybe. I would love to see Walker from Wisconsin with Nikki Haley as the vice president. That's what I would love to see. You know why? Because they both told the unions to go screw themselves. I don't believe in paying people $50 an hour for a $15 an hour job or a $20 an hour job. I don't believe in that. All right. So, plug and chug. du is what? Square root of 5 cosine theta. That's right, class. Square root of 5 cosine theta over u, which is square root of 5 sine of theta, times this, which is what? I done got mixed up. Here we go. Square root of 5 cosine of theta. Of course, the square root of 5s can come out. What happens to cosine? And that's going to be left with square root of 5 over 5 antiderivative of 1 over the sine of theta, d theta. And what's 1 over the sine? Cosecant? Thank you, class. Square root of 5 over 5 times the antiderivative cosecant of theta, d theta. And I have no idea what the derivative of cosecant is. I meant the antiderivative. So you have to look it up if you can't remember it. What is it? Natural log of cosecant minus cotangent? You might have to look it up. So let's take this. Let's just do this. All right, somebody help me out. That's square root of 5 over 5. What is it? The natural log of what? Cosecant minus the cotangent. Somebody help me out. Which one is it? I'm going by, because they didn't even do it. I'm thinking it's the cosecant minus the cotangent, because they didn't even show me the explanation. They just went to the answer. Cosecant of theta minus the cotangent. Y'all need to look in your table and see if I'm correct. I think that's right. Cosecant minus cotangent of theta. I think it's right. Let's see. And then we need to find the cosecant and the cotangent. Well, the cosecant is the relationship with the sine. Do we have the sine? We've got the sine right here. So the sine of theta is equal to x or u over what? Square root of 5. So the cosecant of theta is equal to the square root of 5 over what? U. So that's that. And then the cotangent. What's the cotangent? 1 over the tangent. We don't have the tangent, do we? So we're going to have to go back to our handy dandy. Let's go back to our handy dandy. There we go. What's the tangent? Oscar had a hump of apple. So that's of apple. U over this. So u over the square root of 5 minus u squared. U over the square root of, what was it, 5 minus u squared. So what's the cotangent? Square root of 5 minus u squared over u. Thank you, class. So now we've got the cosecant and the cotangent, and we've got the square root of 5 over 5 natural log of square root of 5 over u minus square root of 5 minus u squared over u plus c. I'm thinking that's probably going to be the answer. Let me look and see what they got. No, they just did the 3 dots and went. That means you already know how to do it. They got 1 over the square root of 5 natural log of square root of 5 minus 5. Yeah, they put it all over u. But how did they get 1 square root of 5? Did they rush? Let's see, 1 square root of 5, 1 over square root of 5. How did they get that? We got everything right except for the square root of 5 over 5. So somebody help me out there. Where did I go wrong? du, what is du? Du is 5 square root of 5 sine of theta over u. Oh, I'm sorry. Du is square root of 5 cosine of theta. Square root of 5 sine of theta.
Did you cancel the cosine?
Uh-huh.
Did you not just cancel the square root of 5 cosine and the square root of 5?
Well, see, I just brought here. I found it. They just got the first couple of steps and the last step. That's all they got. Hold on. They've got square root of 5 cosine of theta over square root of 5 sine of theta times the square root of 5 cosine of theta. I've got that, right? Well, the 5 cosine of theta, square root of 5 cosine of theta, they basically cancel out. I didn't cancel, I don't know why. Square root of 5 times square root of 5 is 25, which is 5. I've got the right answer. I've just got it written in a different way because even if you cancel these two out, is that what you were talking about? Yeah. Even if you cancel that out, you get 1 over the square root of 5. That's it. 1 over the square root of 5 times square root of 5 over square root of 5 is equal to square root of 5 over what? 5? That's what I got. I got the same thing. They just left it. They didn't rationalize the denominator. So that's it. Yeah, go ahead. Get on out of here. Get mad. Quit. All right, so that's 7.3. Let me get the roll. Keep the bureaucrats happy. I think everybody's here today. Who's not here? Anybody? Huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Huh? Oh, Mr. Urban's not here.
He came by.
Yeah, I got it. I think he had to get smokestacks on his Honda. Let's see. How many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Everybody was here today. Wow. I'll get an email that says, "Are you sure you took the right attendance?" I get an email whenever everybody's present. There are people.
It's a 2-hour Cal 2 class at 8 a.m. at Anderson.
Yeah. Are you sure you took attendance?
Take care.
I have to see you. I have people. There are people actually paid at Tri-County Tech to watch attendance.